All right, today we are diving headfirst into a real cosmic cold case. We're talking about a mystery of missing monsters that has had astronomers scratching their heads for years. We're going to explore how scientists finally tracked down some of the universe's biggest and most elusive hidden giants. So get this, the central puzzle is pretty straightforward. Our best theories told us that the really early universe should have been absolutely packed with supermassive black holes. But when we actually looked, a whole lot of them were just gone. It's like expecting a stampede of elephants and only seeing a couple. The question was a big one. Where on Earth were they hiding? To even start to answer that, we've got to go way back in time, back to the very beginning of this cosmic detective story. Now, the scene of the crime, if you will, is a fascinating time called Cosmic Dawn. We're talking about the period less than 1 billion years after the Big Bang itself. This is when the very first stars and galaxies were just starting to flicker on, lighting up the cosmos for the first time. And it's in this chaotic, brand new universe that our suspects were supposed to be running rampant. And this is where the real head-scratcher starts. You see, finding these giants was absolutely crucial. If there were a lot of them, it would mean they formed all over the place, pretty easily. But if there were only a few, it would suggest they needed some really special, rare conditions to exist. The problem? The numbers just weren't adding up. What we were seeing didn't match the theories at all, and just like that, a huge cosmic mystery was born. So if the theories were right and these giants really did exist, then they must have had the perfect disguise. Let's take a look at how they managed to hide right out in the open. The key fingerprint of a supermassive black hole is something we call a quasar. Just picture a black hole that's having an absolute feast, greedily sucking in all the gas and dust around it. All that material spins into this superheated, glowing disk that shines with an incredible, unbelievable brightness. Sometimes it's brighter than entire galaxies. This thing is basically a cosmic flare gun that should make them super easy to spot. So why weren't we seeing them? Well, here's the trick. You see, most quasars we find are what you'd call unshrouded. Their super bright ultraviolet light just travels through space, no problem. But astronomers had this growing suspicion that a whole other population of shrouded quasars was out there, ones that were wrapped up in these incredibly thick clouds of cosmic dust. That dust acts like a super dense fog, completely blocking all that bright UV light from ever reaching us. And just how good is this disguise? Well, these dust clouds are so incredibly dense, they absorb, get this, 99.9% of the ultraviolet light. That is not a disguise, that is an invisibility cloak. It's the ultimate cosmic stealth tech, and it's no wonder these titans stayed hidden for so long. So, to see through this cosmic fog, you can't just use the same old tricks. Astronomers needed a totally new approach. They needed the ultimate detective duo. And their strategy was honestly brilliant. First, they used the Subaru Telescope in Hawaii as their scout. It has this huge field of view, so it scanned a massive patch of the sky, looking for any galaxies that were suspiciously bright but didn't look like a normal quasar. Then, once they had a list of suspects, they called in the specialist, the James Webb Space Telescope. The JWST's incredible infrared vision can basically pierce right through those thick dust clouds, kind of like thermal goggles cutting straight through smoke. And the team leader, Yoshiki Matsuoka, really summed it up perfectly. He said, this kind of discovery just wasn't possible with one telescope alone. It took this powerful combination of the scout finding the targets and the specialist confirming them. It was a total team effort. Okay, so the stage is set. The suspects are identified. The high-tech tools are in place. It was finally time for the investigation to pay off. This is the moment the case finally broke wide open. The Subaru Telescope did its part, handing over a list of the most likely hideouts. From that list, the team zeroed in on the 11 most luminous and suspicious galaxies. These were the prime targets that they pointed the James Webb Space Telescope at. And bingo. Peering straight through all that dust, JWST confirmed that seven of those 11 galaxies were indeed hiding active, feasting, supermassive black holes. This was it, the first ever confirmed discovery of these dust-shrouded quasars at cosmic dawn. The cosmic cold case finally had its breakthrough. Now, a discovery this huge doesn't just solve one mystery, it changes the whole story. Let's look at how this finding is forcing us to build a completely new picture of the early universe. So here's the real kicker.
The number of hidden quasars they found strongly suggests that for every quasar we could already see, there was another one hiding in the dust. I mean, think about that. It means the total population of supermassive black holes back at cosmic dawn, well, it could be double what we thought. We were literally missing half the picture all this time. And that changes everything. A much bigger population of these things so early in the universe's history puts a ton of pressure on our theories. How did they get so big, so fast, if there were twice as many of them as we planned for? It forces us to completely rethink how the first galaxies were built and how these hidden giants shaped them from the inside out. We aren't just adding a footnote here, we are rewriting a major chapter of cosmic history.
So it turns out some of the universe's most powerful objects were hiding in the most unassuming places. You know, solving this one incredible mystery has just blasted open a dozen new questions. And it really, really makes you wonder, right? What other cosmic secrets are still out there, just waiting for us to find the right way to look through the dust?